Okay, so for this unit, the first part of the unit, we're going to focus on parametric equations. So parametric equations are a set of equations in which the coordinates are expressed in terms of a parameter. So we are going to, instead of just x and y, we're going to have another parameter, and usually the parameter is either time or it's going to be an angle measure. So we're going to have two equations now for our parametric equation. We're going to have an x equals equation and a y equals equation. So these are called parametric equations. You're used to working with just one equation, which is called a rectangular equation. So the x will represent our horizontal position. So the x represents the horizontal position. So if you can see on this graph here, horizontal distance is on the x-axis, whereas our y value represents our vertical position or our vertical distance. So this can tell you at any certain time what x and y value we're going to be at. So we're going to graph these by hand, and then I'm going to show you how you can actually graph them on the calculator. So graphing parametric equations. So see how we have two equations. We have an x equals equation and we have a y equals equation. So in order to graph this, we're going to need to get ordered pairs for x and y so we know what points to graph. So I'm just going to do the x equation first. So the equation for x is t plus 2. So I have a few times over here, 0, 1, 2, 3, 4. Now these times could go up forever, but we're just going to do through 4. So if we plug in 0 for t into our x equation, that would be 0 plus 2, which is going to be 2. And then if we do t plus 2, if we plug in 1, that's going to be 1 plus 2, which is 3. 2 plus 2, which is 4. 3 plus 2, which is 5. 4 plus 2, which is 6. Okay, so then if we use our equation for y is equal to t squared. So if we plug in 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So now we have ordered pairs, x and y values that we can graph. So if we go over here to the graph, we're going to plot the first point 2, 0. So over 2, up 0, and then we have the point 3, 1. We have 4, 4, 5, 9, then we have 6, 16, which is going to be off the chart, but 6 be somewhere up here. Okay, so we have a curve here. Looks like part of a quadratic, and it would keep going up forever. And it does say show the direction. So the direction means which way your graph's going to go. So depending on the time, I graph these points in the correct order because I started with time 0. So that means that my graph will continue in this direction. So these little arrows here just represent the direction it's going in. So that's a thing about parametric equations that actually shows you the direction that it's going. So let me show you how you could graph this on the calculator. So if you go to your calculator and you're going to change, you're going to go to mode, and we're going to change, instead of where it says function, you're going to change it to parametric. So instead of function, parametric should be highlighted. And once you go there, now you can go to your y equals, and you notice your y equals doesn't just say y equals, it says x equals and y1. So for x1, I'm going to put, if you just hit the x button, it'll make it a t. So t plus 2. And then if you hit the x button, that'll make it x squared. So there's my x and y parametric equations. So I'm going to hit graph. And you can see that we have our graph here, which looks similar. Now ours is more curved, but it's just the way that this is graphed. If you wanted to trace and see if you have the correct points, like see how as t equals 0, the point is 2, 0. Or if we did t equals 1, see how the point is 3, 1. And it tells you those x and y values that go with that certain time t equals 1. So I just wanted to show you how to put that function on the calculator in parametric, but you mainly need to know how to do it by hand. Okay, so we have a couple more here just to see. So we're going to make a table, graph it, and we're going to make sure we do the direction. So if we do our x value, it's 3 minus t. So 3 minus 0 is going to be 3. 3 minus 1 is 2. 3 minus 2 is 1. 3 minus 0 is 3, or sorry, 3 minus 3 is 0. 3 minus 4 is negative 1. So then for our y values, we're using the equation 2 plus t. So 2 plus 0 is 2. 2 plus 1 is 3. 2 plus 2 is 4. 2 plus 3 is 5. And 2 plus 4 is 6. So those are our values that we need to graph. So if we plot those points, we have over 3 up 2. We have over 2 up 3. Make sure you're plotting them in the, follow this table so you know the direction they're going. And then we're at 1, 4, 0, 5, and then negative 1, 6. So it's going to keep going in this direction. And we could put these directional arrows on here to show that this is the direction it's going in. So that's why you always make sure you start with t equals 0 when you're graphing. So you could confirm this in your calculator graph if you wanted to. Okay, so the last one for graphing, x is 2t. So 2 times 0 is 0. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. And then y is the absolute value of t minus 1, so make sure you make your answer positive. So 0 minus 1 is negative 1, but if we make it positive, that'll be positive 1. 1 minus 1 is 0. 2 minus 1 is 1. 2 minus 3 is 2. Sorry, 2 minus 1 is 1. 3 minus 1 is 2. 4 minus 1 is 3. Okay, so if we plot those points, we have over 0 up 1, over 2 up 0, over 4, 1, 6, 2, and 8, 3. So this is making a V shaped here. But it would keep going that way, so we could put the direction is going to go down, and then it will go up like this. So that is how you graph parametric equations. So they're going to give you an x equation and a y equation. Our parameter here was time because we were talking about t. You have your different times that you're going to make. So if you have to make your own chart, you would make a table. I would do the times up to 4, which is good. You figure out your x, you figure out your y. That gives you your coordinates that you can point. But parametric equations does tell you what your direction it is going to go. Okay, for the next part, it says, suppose a particle is moving across a coordinate plane in a straight line, and that position of the particle at time t in seconds is given by the following parametric equation. So we have an x equation, a y equation. Our parameter here is time. So for the first part, it says give the coordinates of the particle at the given time. So when it says the coordinates, that's referring to, we just want to find what the x and y value are going to be at the certain time. So if we are given 30 seconds, we can do x of 30. So we're just going to plug in 30. So if we do 3/5 times 30, and this is just in your calculator typing this in on the regular part, but this is just 3/5 times 30, and that'll give us 18. And then to get the y value, we're going to plug in 30. So 1/5 times 30 plus 3. And that will give us 9. So our coordinate here is 18. 18 is the x value, 9 is the y value when our time is at 30 seconds. So then we're going to do the same thing for 8 seconds. So we're going to have x of 8. So we're going to plug in 8 for t. So if we plug in 8 for t, we have 3/5 times 8, and that'll give us 4.8. And then we're going to plug 8 in for y. So 1/5 times 8 plus 3. And that will give us 4.6. So my ordered pair here, the x value is 4.8, the y value is 4.6. So parametric equations let you figure out what your x, which is the horizontal distance, and your y, which is your vertical distance, all at a certain time. Okay, so then it says determine whether the particle is ever located at the given coordinates, and if it is, we want to tell when. So what we want to do here is we want to figure out if this is our x value and this is our y value, does that really work with those parametric equations? So what I'm going to do here is I know that x, the equation, is 3/5 t. So I'm going to plug in the x value that we have. So the x value that they've given us is 33 equals 3/5 t. So I want to solve for t. So to solve for t here, I'm going to do 33 divided by 3/5. And let's see what that gives me. This is going to give me t equals 55. Okay, so if the time is 55, I want to check and see, is that going to make a true statement for y? Well, I know y is 1/5 t plus 3. So I'm going to plug in t as 1/5, or sorry, I'm going to plug in t as 55. So if we calculate 1/5 times 55 and then plus 3, this gives us a y value of 14. Well, is that the y value that it's supposed to be here, 16? No. So this is not 16. So it says determine where the particle is ever located at the given coordinate, so not located at this coordinate. Okay, for it to be located at the coordinate, we would have had to have the answer y to be 16. Okay, so for part B, we have 2411. We're going to do the same type of thing here. So for 2411, the x value is 24, the y value is 11. We're going to use our x equation as 3/5 t. We know that x is 24. We're going to figure out what t is going to be. So we're going to do 24 divided by 3/5, and this will give us 40. Okay, so we want to check and see if t is 40, will this work in our y equation? So y is 1/5 t plus 3. We're going to plug in t as 40. So if we do 1/5 times 40, and then add 3, this gives us 11. Well, that is the y value that we have here. So that means that this coordinate does work, and it said if it does work, tell when. So when would be the time. So the time would be 40, and this is in terms of seconds. Okay, so that's just confirming. So those are just ways to see how we graph. You just have to have your x and y. If it asks you for the coordinate, you figure out x and y. If it wants you to figure out if the coordinate works, you're just testing to see if your x and y will work based off your parametric equations. Parametric equations are two equations, one equation for x, one equation for y, that gives you what's happening at a specific time or at a specific angle.